Hello there, this is video 10.3 on geometric sequences. Now our objectives here, just like we did for arithmetic sequence, we're going to use the geometric sequences with the formula and we're going to find sums of the geometric sequence. So our vocabulary, we just have two words. We have geometric means and geometric sequence. We'll get to those in a second. Let's start with our key concept. Just like an arithmetic sequence, we have a formula for if we wanted to find the nth term of a geometric sequence. That formula is simply a sub n equals a sub 1 times r raised to the n minus 1. So it's important to understand that for the geometric sequence. So a sub n represents the term, all right? So if we wanted the 100th term, this would be a sub 100, or another way of writing it would be if we were just doing functions, it's like saying f of 100. That's what a sub 100 would mean, or a sub n. A sub 1 is the value of the first term. So the first term is 5. A sub 1, right? This is our x, this is our y. We said it's like saying f of 1 equals 5. And then r is going to be our common ratio. That's the value that we multiply every term by to get the next term. And n tells you is going to match what term we're talking about, n minus 1. So order of operation is important. So remember, it's a sub 1 times r raised. So exponents come first. You must simplify this factor first before you can multiply it to a sub 1. You can't multiply a sub 1 in r and then take it to the n minus 1 power. So basic math and exponent rules. So let's look at the first example. It goes to the beginning of the chapter, and it talks about let's see if I can pull this up. So I need to go back a couple pages. The patterns of emails. So we'll read that, and then we'll look at the real world example. Here it is. Okay, it says Julian sees a new band at a concert. He emails a link for the band's website to 5 of his friends. They each forward the link to 5 of their friends. The link is forwarded again following the same pattern. How many people will receive the link on the 8th round of an email? So here we have to break down what's going on here. So what do we have? We have a sub 1, right? We know is he sends out 5 emails. And what is R? So each one of those persons sends it out to 5 more. So our common ratio is also 5. And they want to know how many emails will be sent in the 8th round. So we know n is 8 because we want to know the 8th term. And so what we're looking for is a sub 8 is what we're finding out, because they want to know how many emails in that 8th term. All right, so we start off with our formula. So our formula is a sub n equals a sub 1 times r to the n minus 1. So if we want to find a sub 8, I fill in 5 times 5 to the 8 minus 1. Well, these are exponents, so technically you have 5 to the first times 5 to the 7th, the same base. So in this instance, you can change it to using exponent rules as 5 to the 8th. And then if we simplify this out in our calculator, because I can't do this in my head, and I'm not going to, it's 390,625. So we just simply put it in our calculator. So on the 8th round, that's how many emails they're sending out. So 8 is going to be 390,625. All right, pause the video, do the guided practice, and we'll move on to example 2. Okay, so example 2 asks us to write an equation for the nth term. So they give us the sequence, the pattern. So they give us 0.5, 2, 8, 32. It says write an equation for the nth term of a geometric sequence. So we have to start off with, what is our formula? A sub n equals a sub 1 times r to the n minus 1. All right, so what's our common ratio? So we're going to find this. We're going to do 2 divided by 0.5. Okay, you can put this in your calculator, or you need to know to write it down or do it correctly. This equals 4. Just like this is 8 over 2 is 4, and this is 32 over 8. So we have to make sure it is a geometric sequence. It is. They tell us it is, so we can assume. So we know, what values do we know? We know r is 32. Do we know a sub 1? Isn't this my first term? So a sub 1 equals 0.5. So my formula is going to be a sub n equals 0.5 times 32 to the n minus 1. And oops, I did this wrong. Okay, so r is 4. Oh, sorry. We don't need to put 4 in here. So a sub n equals 0.5 times r to the n minus 1. That's our equation there. We just want a general equation, so if we wanted to find the 6th term, 7th term of this value. All right? So now they want us to find, on part B, they want us to find a sub 4. They tell us a sub 4 is 5 and r is 6. So again, we're writing the equation. So let's start with this. So they said a sub 4 equals 5 and r equals 6. And our equation is a sub n equals a sub 1 times r to the n minus 1. All right? So we need that r. In order to write this equation, we do need a sub 1 and we need r. Well, we've got r, it's 6, but we don't have a sub 1. So we can go back to our formula and put what we have in. So we know 5 equals a sub 1 times 6. This is a sub 4, it's 4 minus 1, which is 3. And we get 5 equals a sub 1 times 216. A sub 1 equals 5 over 216. So now I have a sub 1, which is 5 over 216. And so now I can write my equation. A sub n equals 5 over 216 times 6 to the n minus 1. And there's your equation. Okay, so pause the video and do the 2 guided practice, and we'll move on to example 3. So example 3 talks about our first vocabulary word, geometric mean. What does geometric mean? Just like arithmetic means, geometric mean is the term or terms between 2 non-consecutive terms of a geometric mean. So let's look at example 3. They want us to find 3 geometric means between 2 and 1250. Okay, so they tell us there's 3 values in between here. So we're going to write our lines. All right, this is term 1, this is 2, 3, 4, and this is term 5. So what do we need? We need a common ratio. We need an r. Okay, but what's given to us? What's given to us is a sub 1 is 2, a sub 5 is 1250, and n is 5. So if we put it in our formula, a sub n equals a sub 1 times r to the n minus 1, can we find r? Yes. So a sub n is 1250. So now we just go in and put the values in. So a sub n is 1250. A sub 1 is 2. We don't know r, but we know n. So 5 minus 1 is 4. So we can divide by 2, and we get r to the 4th. I'm just rearranging this, just using algebra. Skipped a couple of steps in my head. So I need to take the 4th root. So r equals plus or minus 5. Now remember, we were taking the 4th root, not the square root. When we take an even root, when we're solving an equation, unless we're looking for quantity or measurement, then you're going to have 2 solutions, a plus or minus. So I'm going to have a positive 5, so that's going to be 10, 50, and 250. Then I'm going to have negative 50, so I'm going to have a second group of numbers. I'm going to have negative 10, positive 50, and negative 250, because now I have to do. So I have 2 sets of solutions because I had a plus or minus. So be very careful when solving using some basic algebra rules. Now pause it, do the guided practice 3, and the next piece of this is we're going to move on to is geometric series. Just like an arithmetic series, so for instance, I'm going to take that a series of 2, 8, 32, and 128. So, sorry, this is together. So I have 4 terms. So if I wanted the sum of the first 4 terms, that's called the partial sum, right? I would just find each value and I would add them together. If I wanted just the sum of the second through 4th term, then I would find the 2nd, 3rd, and 4th term and add them. Now that's pretty easy if it's low and it's small numbers and it's easy to add. But what if I wanted the partial sum of the 100th term all the way through the 250th term? So first of all, it would take me a long time to manually write this out, to find the 100th term and every term between there and 250, and then to go back and add them up. That would be a long, tedious process, and I'm more likely to make mistakes. So what I can do is, just like in arithmetic, we have 2 formulas. We have 2 formulas. So the first one is when you're given a sub 1 and n. The second one is when you're given a sub 1 and a sub n. Okay, so the formulas are s of n equals a sub 1 minus a sub 1 times r to the n over 1 minus r. The second one is s of n equals a sub 1 minus a sub n times r over 1 minus r. Okay, just like before, we've got 2 sets of formulas. Doesn't matter, we just got to make sure we have the right parts. So let's go back and look at example 4, which it refers back to our real world problem. Okay, so example 4 says, so here's our formulas, right? So know these key concept boxes. This is, if the pattern continues, what is the total of emails sent in the 8 rounds? So basically we've got term 1, 2, 3, 4, 5, 6, 7, 8. So we had a sub 1, which was 5. We found a sub 8 in our example earlier, right? So that was, I'm going to write out here because it's a big number, 390,625. And we knew that r was 5, and we said n was 8. So the formula that we want to use uses s of n equals a sub 1 minus a sub 1 times r to the n over 1 minus r. Do I have a sub 1? I sure do. Do I have r? I do. Do I have n? I do. So I can put this in this formula, 5 minus 5 times 5 to the 8th over 1 minus 5. Using the algebra, remember this has to come before. You cannot subtract these. Order of operation. And then we have to do this first. But they're the same basis. I can use exponent rules. So I get 5 minus 5 to the 9th power over 4. You must do 5 to the 9th. You cannot do 5 minus 5 or you get the wrong answer. If you put this all in your calculator, you're going to get 488,280 emails are sent after round 8. So we found all these values here and we added them up. This is the amount that we would get. All right, so pause it, do the 2 guided practice, and we're going to move on to example 5. So example 5 is still a partial sum, except for now we're going back to using sigma, which is a Greek symbol, and it's just a shortcut for writing the partial sum and the information that we want. So we have to understand what are the pieces here. Okay, so this right here is going to be your r. Okay, the base is r. This is going to be just the number of times, so we got to make sure we multiply it here. So for instance here, they want us to find the sigma notation. So we need to find what a sub 1 is. A sub 1 is we put this 3. Remember, this is the first term that we need to get, and this is the last term, the nth term, okay? So we put 3 into here. So 3 minus 1 is 2. 2 squared is 4 times 4. So a sub 1 is 16. We know r is 2, and n is 10 minus 3 is 7 plus 1 is 8. So I have 8 terms between the 3rd and 10th place. Okay, so here's my formula. So now I can just put it in here and do 16 minus 16 times 2 to the 8th power over 1 minus 2. Again, don't forget order of operation. So when we multiply this out and subtract it and divide it, we end up with 4,080. Now you can also put this in your calculator, and we will be doing that in class. So we've already learned how to do. We do it the same way we do arithmetic. We find the sum button, we enter a variable equals 3, and then 10 up here, and then our formula is 4 times 2 raised to the variable minus 1. All right. Guided practice 5A and 5B, and let's go to our last example, 6. It says, so we can also use this formula to find a certain term. So they want us to find a sub 1 in a geometric series, so we know it's geometric, so we have to pay attention when we're doing this on the test, that we know the difference between arithmetic and geometric. They have different formulas. For which S of n, so this is what we need to find, S of n equals 13,116. They tell us n is 7 and r is 3. So let's take our formula, a sub 1 minus a sub 1 r to the n over 1 minus r. So I'm looking for a sub 1. Do I have an r? Yes. Do I have an n? Yes. I have an s and n. So this is really simple. I just plug in the values for the formula. So 13,116 equals a sub 1 minus a sub 1 times 3 to the 7th power over 1 minus 3. This is where you got to know algebra and how to solve. Well, I'm going to parentheses, and I know this is equal to 2, so I'm going to multiply both sides by 2. And then I'm going to get negative 2, sorry, because it's negative 2. So then I get negative 26,232. And I'm going to factor out an a1, which leaves me 1 minus 3 to the 7th power. But I must do 3 to the 7th power first. And then I can do 1 minus it. And then I'm going to divide by 1 minus 3 to the 7th power to both sides. So 1 minus 3 to the 7th power. And when I put this in my calculator, I get a sub 1 is 12. All right? Stop the videos, do the last guided practice, and we will see you in class.